Today we're going to be talking about inverse functions. By the end of this video, you'll be able to find the inverse of a function, and you'll be able to use compositions to verify that two functions are inverses. So first, we need to define what an inverse function is. An inverse function is a function that undoes another function. To find an inverse function algebraically, we talked about how to find inverses graphically earlier this year, but to find the inverse algebraically, we need 4 steps. First, you need to change f of x to y. Then you need to switch the x and the y in the equation. Then you need to solve for y. And lastly, you need to change the notation. You change y to f inverse of x. This right here is the notation for the inverse of f of x. So let's look at a couple of examples. First, we want to find the inverse of f of x equals x plus 4. So we're going to start by changing f of x to y. Then we're going to switch the x and the y. Then we need to solve for y. So to solve for y, you need to subtract 4 from both sides. So this is step 1, step 2, step 3. Step 4 is to change the notation. So I'm also going to flip it around. So I'm going to say that the inverse of f of x is x minus 4. And that's our final answer. The next problem says a of x equals 2x minus 1. So our first step is to change a of x to y. Then our second step is to switch x and y. Then we need to solve for y. So first I'm going to add 1 to both sides. Then I'm going to divide both sides by 2. I'm going to end up with 1/2 x plus 1/2. And then my last step is to change the notation. Since this started out as a of x, I'm going to write my final answer as inverse of a of x equals 1/2 x plus 1/2. Our next example is x squared plus 3. So my first step is to change h of x to y. Then I need to switch x and y. Then I need to solve for y. So I'm going to subtract 3 from both sides. Then to get rid of the square, I need to take the square root of both sides. Then my last step is to change the notation to h inverse of x equals square root of x minus 3. And this fourth problem says g of x equals cube root of x plus 2. So our first step is to change it to y. Then we need to switch x and y. Then we need to solve for y. So I'm going to subtract 2 from both sides. Then to get rid of the cube root, I need to cube both sides. Then my last step is to change the notation. So I have inverse of g of x equals x minus 2 cubed. So that's how you find the inverse of a function. But sometimes you are given two functions and asked to prove if they are inverses. To do that, you need to use compositions. So to prove that functions are inverses, both f of g of x and g of f of x have to equal x. If they don't, they are not inverses. So if you see in the directions where it says determine if they are inverses, or prove that they are inverses, or show that they are inverses, you have to use compositions. So for this first example, I need to do two compositions. I need to do f of g of x and g of f of x. So if you go ahead and write both of those down, that'll help you remember to do both of them so you don't finish one composition and then forget to do the second one. So we have that f of x is 4 minus x and g of x is x plus 4. So if I'm going to do f of g of x, I'm going to start with f of x and then I'm plugging g of x in for x. So we need to remember to distribute the negative. So I have 4 minus x minus 4, which leaves me with negative x. We need both of these compositions to equal x. So since this one does not, it means that they are not inverses. But I'm going to go ahead and check g of f of x as well. So for g of f of x, I'm going to start with g of x and plug f of x in for x. So I have 4 minus x plus 4 gives me negative x plus 8. So these are definitely not inverses. Let's take a look at another example. I have that f of x is the cube root of x minus 3, and that g of x is x plus 3 cubed. I need to do f of g of x and g of f of x. So for f of g of x, I'm going to start with f of x and plug in g of x. So you know that cube root and cube are inverses. They cancel each other out. So those cancel, and I'm left with x plus 3 minus 3, which is x. So far it looks like they are compositions, but I need to check g of f of x as well. So if I start with g of x, I need to plug in f of x. So you always start inside the parentheses, So the minus 3 and the plus 3 cancel out. I have cube root of x cubed. And we just said that cube root and cubed are inverses and they cancel each other out. So we're just left with x. So since both of these equal x, these are inverses.